This is your Pac-Man GP. Ladies and gentlemen, how have you been? I hope you had a wonderful weekend and it's time to record and post one more video of an interesting invention. So I'm going to present an invention for which an Indian patent has been granted by the Indian Patent Office. Today's invention is related to the field of, I would say to the field of electronics, electrical and electronics in a combined manner. So without wasting any further time, I'm going to present my screen. Okay, so the title of today's invention is a light sensing device for operating an electric light bulb and a method to operate the same. But before I begin with explaining what is today's invention, I want to put a small sort of a condition here that I will be mainly focusing on the device part of this invention and not the method part, because if I have to explain the method also in the same recording, then the recording will stretch a bit far, and perhaps that is not advisable. So I'm going to restrict today's presentation only to the device, and perhaps I'll record another sort of a video just to explain the method, maybe later on, maybe in the next week or sometime in the near future. So having said that, I'm going to restrict this video only to the device. So it's a device which is called as a light sensing device for operating an electric light bulb. And as I told you, an Indian patent has already been granted by the Indian Patent Office for both the device as well as the method, but I'm going to restrict myself only to the device today. So the granted Indian patent number is 427992, and the Indian patent has been granted in the name of one Mr. Mohan Mani Krishna Karimsetti. Okay, so first of all, congratulations to Mr. Mohan for acquiring this patent in his name, and I hope the inventor is able to scale it up and create a business model around this granted patent very soon. So all the best for that too. Having said that, I'm going to dwell a little bit on the drawbacks which the inventor has identified in the prior art and which has been disclosed in the complete specification, in the granted complete specification by the inventor. Okay, so so far as electric light bulbs are concerned, now we all know what is a light bulb. It is a very important as well as a very well-known home appliance, which is used in every home, in factories, in commercial spaces, in residential spaces, so on and so forth. So an electric bulb has to be switched on whenever the need is required by the user, and it has to be switched off when there is no need of that extra light, especially after nightfall, during post evening time, when there is dark. The operator has to physically switch on the bulb, and during daytime, when there is natural sunlight, natural light coming in working spaces or in commercial spaces in the homes, the bulb has to be switched off physically. But here it so happens that sometimes the operator or the user may forget to switch off the bulb, and that may lead to consumption of energy and wastage of wastage of power and energy. So that is the main and a very simple drawback which is identified by the inventor from the prior art. Okay, and in order to overcome this particular drawback, our inventor has conceptualized this particular invention, for which the title is a light sensing device for operating an electric bulb. So I'm going to restrict myself only to the device, as I mentioned. So moving on to the next slide. This is maybe a section, you can say a sectional front view of the device. So here we have at the number 100, we have the light sensing device. But before I move on, I would urge our viewers to please subscribe to my channel, and also share your thoughts on in the comments, and I'll be more than happy to answer and reply to your comments. Also share my videos as much as possible with your friends, and help in making this channel at the rate of Pac-Man GP a viral one. So moving on, as I mentioned, at number 100, we have a light sensing device. Okay. And towards the bottom, we have a casing which is denoted by the number 108. Okay, so this is the casing in which most of the the electrical equipment is sort of located, or it's placed. Um, on the left side, we have a projection that is coming out, and on the top at number 104, we have a light dependent resistor sensor, which is popularly called as the LDR sensor. Okay, and this LDR sensor is electrically connected with a PCB, or a printed circuit board, which is at 112, which is placed inside the casing through the sensor wires, which is denoted by the number 106. Okay, so at 104, we have an LDR sensor, and it is electrically connected through these wires. I mean, the dotted lines are practically the wires as shown in the drawing. Okay, and these sensor wires are helping the sensor to communicate with a printed circuit board, okay, at 112, which is placed inside this particular casing. So on the top, we have the light bulb holder. So the bulb is sort of detachably connected in this particular holder. On the printed circuit board, or the PCB, we have a relay. Okay, now this relay is again electrically communicating with the light, with the bulb which is connected on the light bulb holder. The light bulb holder is denoted by the number 118. Okay, and there is one very important component that is a part of the PCB, wherein the PCB itself is a part of a circuitry unit. Okay, that circuitry unit is denoted by number 120. It's mentioned in the succeeding diagram, which you will get to see. But the PCB, the printed circuit board, is part of that circuitry unit. The relay is also a part of that circuitry unit, and there is one comparator. Okay, that is one more component which is part of the PCB. Okay, now what is the function of this comparator? There is a reference voltage that is configured in this particular comparator. So during the working of this particular device, what happens is that the LDR sensor, it sort of senses the luminosity of the ambient atmosphere. The ambient atmosphere is the atmosphere that is surrounding this particular device. Okay, so whatever is the luminosity, whatever is the illumination, the intensity of the illumination that is available, maybe because of natural light or maybe because of some other light source, all that is detected by this sensor, and it is converted in terms of voltage. It is converted in terms of voltage, and it is communicated to the PCB. Okay, to the comparator which is connected on the PCB, basically. So when that voltage reaches the comparator, there is the reference voltage that is already configured in that particular comparator. The PCB or the controller, it sort of compares that acquired voltage, depending on the ambient luminosity, like the luminosity acquired by the sensor converted into a voltage. That voltage is compared with the reference voltage, which is already configured in the comparator. Now, if that voltage, which is acquired by the LDR sensor, okay, the luminosity acquired voltage, which is sort of acquired by the LDR sensor, if it is more or greater than the reference voltage, then definitely the controller, it senses that enough light is there, and therefore it shuts down the bulb through this relay. It sends a signal to the relay, and the relay shuts down the bulb. It switches it off. Okay, why? Because there is enough light in the surrounding, and therefore the light bulb need not be switched on, or need not remain in a switched on condition. Okay. On the other hand, say during nightfall, or after dark, you can say, the sensor detects that the luminosity is very low. Okay, now that low amount of luminosity in the ambient in the ambient atmosphere or in the surroundings, that is converted into voltage and sent to the comparator. Now that voltage is definitely lesser than the reference voltage that is already configured in the voltage comparator. Okay, so therefore a signal is sent to the relay 116, to now switch on the bulb. So this is the premise on which this particular device is working. There is one more sort of a component over here by the number 120, which is a sensitivity adjustment switch. Okay, now it is a switch which works in 3 modes, that is low, medium, and high. And these 3 modes are utilized by the user physically to adjust the sensitivity of this LDR sensor. So this sensitivity switch is in sort of signal communication with the sensor. And you know how the sensitivity is adjusted, it is based on certain factors. What are those factors? I've listed them over here. So I'll just read it out. The sensitivity of the device 100 is adjusted based on the climatic condition. For example, if at all this particular bulb or this particular device is used in a place which is a hilly region and there is a lot of fog. So definitely the sensitivity of the LDR sensor has to be adjusted so that, you know, maximum amount of luminosity can be acquired or captured by this particular sensor, and therefore a proper illumination of that particular space can be finally acquired. So accordingly, the user will adjust the sensitivity of this particular device with the help of the sensitivity adjustment switch 120, okay, to high. And likewise, if at all you know, low sensitivity is required, enough light is there, so it can be adjusted to low. So depending on the climatic conditions, the sensitivity of the device is adjusted. Then another factor is place of use, such as indoor or outdoor, presence of any reflecting surfaces at the place of use, then luminosity of the electric bulb which is being used in the device. I mean, the luminosity of the bulb will also decide how much sensitivity this particular LDR sensor should have, so that, you know, proper illumination can be finally acquired. I mean, extra illumination is also maybe undesirable in many conditions. If the room is small and the bulb is really bright, it can create a kind of a hindrance in sort of seeing or viewing certain things at a distance. So, you know, adequate illumination can be acquired with the help of this particular sensitivity adjustment switch. I move on to the next drawing. So this is a perspective view of the light bulb holder, and we see the holder in the middle, and it is covered by a plastic cover which is denoted by 124. Now I'll just switch between the previous drawing and this drawing. So we see this particular pipe over here which is carrying the sensor wires from the LDR sensor to the PCB 112. Okay, now in this drawing we see that particular wire which is carrying the sensor wires, these dotted lines, now that is covered by a flexible hose. Now why this flexible hose is important is so that this particular these sensor wires can be sort of shifted towards the area of maximum luminosity. Okay, and therefore the capturing ability, the capturing ability of this particular sensor of the luminosity of the ambient atmosphere, that also gets improved. However, you know, the moving of this sensor from left to right has to be done by the hand by the user. Okay, depending on where the light is coming from, the ambient light is coming from. So for that purpose, this flexible hose comes very handy. We move on to the next slide. Here we have a sensor cap. Now we see that this particular sensor, it is always in this particular sensor, it is always desirable that the luminosity is always captured from the top. Okay, so therefore this particular sensor has only one opening through which the light is captured from the ambient conditions, and then it is electrically communicated in the form of voltage to the PCB. Okay, but in order to avoid light from, you know, going inside the sensor, which is inside this particular cap, this cap in itself, this sensor cap in itself is placed so that, you know, it enables capturing of the luminosity only from this flat surface, and it goes directly and hits this particular sensor, which is denoted by the number 104. Okay, we move on to the next slide. So this is the diagram of the or you can say the top view of the PCB. which is denoted as the circuitry unit. Okay. So at 112 we have the PCB. I'll move back to the previous drawing. So at 112 we have the PCB, the printed circuit board, and this is what it is. Okay, at 112, and we have these sensor wires 106, the dotted lines that we saw in the first drawing. So they are connected to the PCB here, and then we have a LED indicator over here. So this LED indicator, which is also a part of the PCB, in the previous drawing, we see the LED indicator at 134 over here. So the function of the LED indicator is to ascertain whether an alternating current or an AC current is reaching the device or not. So if it is reaching, the LED indicator will be switched on. So that is the only function of the LED indicator. Okay, and this is the general layout of the circuitry unit. Okay, so ladies and gentlemen, this is today's invention. I hope you liked it. Very interesting invention. I guess this is the first invention that is related to electrical and electronics which I have presented on my channel. I hope you liked it. And for more such exciting content on granted patents, please subscribe to my channel, Pacman GP. Please like, please share and comment. This is your Pacman GP.